Wait, I have a really cool place to get some acid.
You what? What? I don't think I can be friends with you if that's the case.
Oh, no, the super labs. We're doing the experiment with the titration and dropping
that acid.
Yeah,
okay.
Yeah, not the one that you put in your nose or whatever you do with it. You would have your nose? I don't know.
I don't know either.
Let's not find
It's
out.
really funny how little we know. Chemistry.
Chemistry. So, a land not so long ago, we didn't really know what acids were.
No, they're actually relatively recent that we've understood them.
Yeah.
As what they are and what they do. At first, they were like a magical thing. They had these special properties.
Well, they could change a few colours. They found indicators, acids could change the colour of them, but they didn't really know why or what was going on.
They could find that they could destroy some vegetables if you put it on there. They can give off some fumes that kill mice.
That sort of thing, but they're like, well, we don't want to just destroy vegetables and kill mice, we want to do something useful.
Yes.
So chemistry happened, and there's this guy called Bronsted Lowry?
Yeah, but well, there was two people. One was Bronsted, one was Lowry. One was an English chemist.
Oh, I see.
One was a Danish chemist. They did stuff on their own. They didn't communicate, and they came to the same conclusion. That conclusion is now called the Bronsted-Lowry theory.
Oh, there you are. And that's where we call our proton donor and proton acceptors. That's from their theory.
Yeah. So back in AS, we had what an acid and a base was, being a proton donor and acceptor.
And that is their idea. So now you were asked to say what is a Bronsted-Lowry acid. That is a proton donor. That's one way of writing it, but it's not the only way.
It's not. That'd be the same for base. It's just the same.
Yeah.
It's just as it was before, but with two new words before it. Nothing new.
So we went a bit further because that doesn't apply to all of the things that act like acids. So there's another guy went a bit further.
Yeah. I'm not sure if you need to know this because it's in the book in the Stretch and Challenge, but we'll say anyway. It's Lewis, is his surname.
Yeah.
He's really recent. He's still alive to this day.
Yeah, so that's how you know science is new and they're still alive.
Lewis
Keep it
acid. This is saying it donates. What's it say? It donates a pair of electrons.
Yeah, electron pairs.
Electron
Electron pair donator, and the other one's an electron pair acceptor. That's really more what's going on.
Because it's not always a hydrogen plus in some cases.
Yeah, in some cases, other things can act as bases. You'll know about, well, hopefully soon if you don't, from my videos, zwitterions and stuff like this, where active acids and bases, which is not just H's.
So, that's enough of that. That's just a short story.
Yeah, that's the story of how we got to acids. Now we're there, a bit more about acids.
Yep. So, the idea that acids, they dissociate when they're in water to form these protons, which is what H plus indicates. H plus is just a proton.
It is, and we know about partial and complete dissociation. That's not the only type, is there?
No, I'm going to go into that in a lot more detail now.
So we have HCl, for example.
Yep, that's got one H per molecule.
And that completely dissociates, hydrogen goes straight away, gone.
Yep, so you're going to have H plus and Cl minus, and your state symbols of being aqueous is important.
It is important because this is where this happens. Yeah, so these are two things that be Cl minus.
Sorry.
That's fine. So that's called a mono-base acid.
Yep.
I'll get onto why in a second. So how about H2SO4, Wayne?
Well, H2SO4 has two hydrogens per molecule. Again, aqueous being important. So this actually does it in two steps, which is why we can go into this monobasic acid being an important thing. This is dibasic, and that means it happens in two stages and eventually donates two protons.
Yeah. So, as it's got two hydrogens, two protons will be released.
Yep.
So, that sort of ends up making it stronger, but it is a di.
And what
That's
it
the
does
first
is it
stage.
sort of does it in two stages rather than just giving a full two.
Yeah.
That
It
will
gives
then
the
go
first
back.
one, and then the rest, then gives the second one.
There's an aqueous after all of this.
Yeah, yeah.
Highlighting it now.
Yeah, sort
That's
of like
two
you
stages.
did lots of stages like this when you were doing first and second ionisation or electron affinity. It sort of feels like that with these equations.
And finally, we're going to have a tribasic.
Yeah,
one
something
that
like
writes it all out as
yeah,
the
like
same thing.
phosphoric acids will have H3PO4, and that'll be one of those, and that'll do a very similar thing.
It will go in three stages, losing one hydrogen at a time to make a minus, then a 2 minus ion, giving a plus each time.
Yeah, and then finally 3 minus. Yeah.
And there you go. That's the summary. That should be 2 minus. I should have said. Sorry.
Yeah, that's yeah. So these are are different types of acids. You need to know what they are, and that's why other stuff reactions can happen. Now you have those. We can sort of think about that and how it affects our base carbonate and metal acid reactions.
Yep. So you should know from AS the reactions off by heart. Now we have to get them down to an ionic equation, which again you did at AS.
Yeah, but sort of just merging ideas together.
Yeah. So we'll do that now. Do you want to pick an acid?
Okay, let's go for H2SO4.
H2SO4,
Sulfuric acid, yeah. And, well, we're going to start with carbonates?
Yeah, it doesn't really matter. Probably won't do every single one.
Yeah, just do carbonates. So carbonates, not what carbonate is, say calcium carbonate, alright. So in AS we know that it's going to form carbon dioxide,
the salts as well.
salts, carbon dioxide and water.
CO2 plus H2O.
But now you need to know all the stages involved with the ionic stuff.
Yeah. So firstly you need to appreciate what's solid and what's liquid in this equation, because those are the things that are solid and liquid you leave alone. They'll be in the final ionic equation.
Yeah.
The things that are aqueous, because they're aqueous, break up into their respective ions.
Yeah, so they'll be in the ionic equation, the rest will be in the complete equation. So this is solid.
This is solid. It's a solid carbonate. It's going to be solid overall.
So that's a solid. So we're not touching that.
This is aqueous, however.
Yeah.
This is also.
That is also aqueous. This, I guess it would be gaseous here.
Yep. CO2 we know is a gas, and water you know is a liquid.
So
this is all at typical temperature.
Yeah. So now you know what we're going to be dealing with.
Only the aqueous is going to break up. So in your intermediate, when you're working out the overall equation,
you write down all your ions you're forming. So you're forming H pluses.
Yep.
You're forming SO4 2 minuses, and you have your Ca2 plus and another one of your SO4 2 minus. So this is where you sort of see which is on both sides, and you start cancelling things.
Yes, you can only cancel them if they're on the other side. So if there was, I can't think of one off the top of my head, but just say there was one that had a H plus on this side, you can't cancel it with this H plus. It has to be on opposite sides.
So now we've done that, we can cancel our two SO4 2 minuses.
And then we leave the rest, because it's an ionic equation we're trying to get to, the overall equation is going to still have this H plus. You still keep it aqueous.
Yeah, and then you add the thing that you leave alone, so your CaCO3. Then you go into your final bit, which is your Ca2 plus, and yeah.
So yeah, you've got your Ca2 plus, because that's stayed normal, that's aqueous still.
And you still have your CO2 and your water.
Now we're not going to go through all the others. As you know, you can react an acid with a hydroxide and an acid with a metal oxide. You just got to think about the state symbols, only break up the aqueous, cancel both sides, and what you're left with is what you're left with.
Yeah, and that's the sort of question you'll get. Ta-da, and that's acids.
Yep. The same thing happens with redox reactions, and that happens when you react an acid with a metal, not a metal oxide.
Yeah.
It's a redox reaction, because the metal part will have been at both, well, it'll be both oxidised and reduced. No, it's a disproportionation reaction.
Both oxidation and reduction will happen within the reaction, but not necessarily to the same species.
Yeah, that's the one.
Yeah.
So that's the same thing, though. You'll have an overall equation. Think about what's solid and gaseous and aqueous and all that.
Yeah.
Same thing.
Alright.
And that's acids.
That is acids. Reminder, as always, if you have any questions from any exam board or exam question, for any of the subjects we do, but especially chemistry in these videos, ask us in the comments below or on Facebook, and we'll get a video back to you.
Yep, and that will be our answer to your question, hopefully.
Hopefully.
Should be.
That's the plan.
Let's do it.
Alright.